All right, your warm-up says write each as a simplified ratio. Remember, these are the ones where we are not typing sine, cosine, or tan in our calculator at all. We're not even pressing those buttons. On these, we're just writing what the cosine of A is. We're not finding A. We're not solving for anything. We're just writing the ratio. So opposite over adjacent, or opposite over hypotenuse, or adjacent over hypotenuse. So practice doing that in the warm-up. Keep your answers as fractions. All right, the first one, cosine of A. Now, to find the cosine of A, to find that ratio, we need, so Katoa says, I'll spell it real quick. We want to memorize how to spell this. So we need adjacent over hypotenuse. So we want the side adjacent to A, we don't know it yet, over 6. Did anyone find the missing side using somebody's theorem? It was a beautiful number, right? 6 squared minus square root of 11 squared is 25. The square root of 25 is 5. Hallelujah for pretty side lengths. Okay, so the cosine of A would be adjacent over hypotenuse, 5 over 6. The sine of A would be opposite over hypotenuse, square root of 11 over 6. And the tangent of C would be opposite of C over adjacent to C. And remember, we always want to simplify our answers. You can't leave an answer as 4/8. You also can't leave an answer as 5 over root 11 because we have that square root in the denominator. So we rationalize, force it to be rational. 5 times square root 11 is 5 root 11. Square root 11 times square root 11 is 11, and is that beautiful fraction as our answer. You can title your notes Angles of Elevation and Depression. This is kind of just a fancy way of saying, hey, we're going to do some word problems today. We're going to take everything we learned about trig, and we are going to try to apply it to a real world situation. All right, so the first angle we're going to look at is an angle of elevation. I want you to think elevate. Elevate, like if you get hurt and they say to elevate your leg, if you have a cast or something, that means to lift it up. So an angle of elevation, you can write this down, is when you're looking up. So for an angle of elevation, it says that it is the angle between the observer's line of sight to an object above and a horizontal line. Now remember, horizontal, vertical, horizontal, vertical. We are dealing only with horizontal in this lesson. We don't care about the vertical at all, unless it's our variable. Okay, so we got the water down here. Pretend that's a straight line. We are in the boat. This is us. And we are looking up at someone else in the lighthouse. So we are headed this way. We are looking up. The angle of elevation is the angle formed by the horizontal and our line of sight. It's the angle formed by the horizontal and that line of sight. So where I put the E with the angle measured, E degrees, that's the angle of elevation. On the ground, looking up. The angle of depression is, of course, just the exact opposite of this. The angle of depression, write it in your notes, looking down. It's the angle between, this sounds familiar, the observer's line of sight to an object below and a horizontal line. We are not in the boat anymore. We have changed places. We are in the lighthouse now. This is us. Yay! And we are looking down at someone in the boat. Now remember, it's the angle formed with the horizontal. It is not this angle right here. That is not the angle of depression. Be so careful. The angle of depression is the angle formed with the horizontal. So the angle of depression is that angle right there. Very important. So angle of elevation, on the ground looking up. Angle of depression, you're depressed, you're sad, you're looking down. So depression looking down, elevation looking up. The great thing about both of these angles is that if I were to draw the angle of elevation in here, what vocab word is there to describe the positions of the angle of depression and the angle of elevation? What vocab word? Very nice. Yes, they are called alternate interior angles, and we know that alternate interior angles are not sometimes congruent, they are always congruent. So the angle of depression is congruent to the angle of elevation every time. So when you find one of them, you've really found both of them. The biggest part of this lesson to me is not the trig. You've got the trig down. The biggest part is, can you draw the correct picture? So we're going to present a problem. I want you to draw the picture without my help first, and then we can work it together. A tree casts a shadow 21 meters long. The angle of elevation of the sun is 51 degrees. What is the height of the tree? All right, hopefully you've had a second to draw it, maybe not. A hint here is that all of these problems are going to involve a right triangle. You're going to have a right triangle every time. It's just trying to figure out where to put the information on that right triangle, okay? The shadow is 21 meters long. Now, shadows fall on the ground. A shadow doesn't float in the air, okay? So your shadow should always be on the ground. The angle of elevation of the sun, remember, elevation is on the ground looking up. So the angle of elevation is going to be right here on the ground. What is the height of the tree? So there's our X right there. What is the height of the tree? I'm going to work quickly through the trig because this lesson is not about the trig. It's about drawing the picture and setting it up correctly. All right, opposite over adjacent. So tan 51 equals opposite over adjacent. X is in the numerator, so we're going to multiply 21 times tan 51, and the height of that tree is 25.93 meters. It's a word problem, so we need a word in the answer, so make sure you put your units, meters. We're going to round to the nearest hundredth unless someone tells us otherwise. A 15-meter pole is leaning against the wall. The foot of the pole is 10 meters from the wall. Find the angle the pole makes with the ground. All right, so we have a wall, we've got a pole, we've got the ground. A 15-meter pole, so be careful. The 15 goes on the hypotenuse. The 15 is the pole. The foot of the pole, that sounds like the ground, the bottom. The foot of the pole is 10 meters away from the wall. Find the angle the pole makes with the wall. Oops, that's a degree symbol. All right, we've got adjacent and hypotenuse. Cosine of x equals adjacent over hypotenuse. Inverse cosine. Second cosine, 10 divided by 15. And we have 48.19. So that would be a 48-degree angle since we round those to the nearest whole number. Okay, we've got a couple more. Joy is flying a kite and has let out 32 yards of string. The kite's angle of elevation with the ground is 35 degrees. If the string is stretched straight, how high is the kite above the ground? So people do get a little confused about the kite and the string. So you want your kite to be the string to be your hypotenuse. That's really important. She's let out 72 yards of string. So make sure the 72 is the hypotenuse because that is where the kite string is. The angle of elevation, we haven't done a depression one yet. They've all been elevation. It's 35. How high is the kite above the ground? How high is the kite above the ground? So that's our X. All right, we've got sine. Sine 35 equals opposite over hypotenuse. X is in the numerator, so we're going to multiply 72 times sine 35. 41.30 it looks like because we have some domino effect rounding happening. And that is yards. This next one's going to be our last one because y'all need to take your quiz. And this one will be an angle of depression one. An airplane pilot sights a shark. Dun, dun, dun. The angle of depression is 26 degrees and the plane's altitude is 3 kilometers. What is the plane's distance from the shark? Now, this might be a little misleading. I might even take this one away so that you can see what the angle of depression looks like. Might take those away. So, it's the angle of depression. So that's going to be this angle right here, 26 degrees. And then it's up to you if you want to draw this altitude and deal with this triangle number 1, or if you want to deal with the triangle I kind of already had placed there and you want to work with triangle number 2. That's up to you, but that 26 would be outside your triangle if you worked with triangle number 2. The plane's altitude is 3 kilometers. So you would have to get a little creative there. Where do I put the 3? Well, an altitude is never a diagonal distance. It's always a straight vertical line. Well, if your triangle is situated that way. So be careful. The 3 is the altitude, and we want the distance from the shark. So here's the plane. Here's the shark. We want the distance from the shark. So that's what we're looking for, D, right there. We've got opposite and hypotenuse. Sine 26 equals opposite over hypotenuse. The variable's in the denominator. Denominator divide. 3 divided by sine 26. 6.84 kilometers away from that plane.